We are going to first go over the warm-up together, and that is going to be our introduction to double and triple bonding. Technically, you watched 2 videos yesterday about double and triple bonding, so you've been exposed to this already, right? What I'm going to do is I'm going to show you again, from my perspective, how to come up with double and triple bonds, and just show you how you can figure out that you need to do them, how to do them, et cetera, and then you will have some time to practice on your own. All right. So hopefully my intention with showing you those videos yesterday is that you get a first pass. You see this for the first time with those videos. And you don't really have to do any practice. You just look at it. And then when I show you, it makes more sense because it's the second time. And then when you go to practice, you're able to try to do some of these. Okay. Like I've mentioned all week, you need a notebook and a pen or pencil. I'm jumping into notes right now, and I'm expecting that you already have your materials ready. Alrighty, these notes don't really make a lot of sense right now, and that's okay. It's gonna make a lot more sense when I show you examples, but I do wanna just give you the rules first of all. Okay. So if you're drawing a Lewis dot structure and you use up all the atoms in the molecule, but you still have single electrons left over that are not bonded, you may need to double the bonds. Okay. So you know that you're going to need a double bond when you have single electrons after you've used up all the atoms in a molecule. Double bonding must occur between 2 atoms that are already bound to each other. There's already a bond there. Otherwise, it's called a single bond, right? It's a first bond. A double bond occurs when atoms are already connected. If the single electrons are on the same atom, or if they're on 2 atoms that are far from each other, you can't connect them, right? You're gonna have to rearrange the structure so that they are on 2 side-by-side atoms. Oops. I know that right now this doesn't make any sense. I know that these words are just words. That's okay. Just copy them down. When we go through examples, hopefully it'll make a lot more sense. Okay? It's okay that this doesn't totally make sense right now. That's fine. I want to show you some examples. Right now I'm giving everyone a moment to copy this down. These notes are available in today's card, but I also want you to take a second to write them down. "30 seconds. All right, let's move on to an example, okay? So the first example that I'm gonna give you is C2H6. Does this have a name? It probably has a name. I don't remember. C2H6, we're gonna start from the very beginning. I'm gonna go through this somewhat fast, right? Because we've done some of these drawings before, somewhat quickly. What I'm gonna do at the end of the day is record, actually, let me do this now. Give me a second. I'm gonna do this in the whiteboard. That way I can save my drawing and put it on the slide afterward. Let's do it this way, because I think that would make life easier for a lot of people. C2H6. That way I can save this drawing and I'll link it to the whiteboard, or sorry, I'll link it to the slides. That way you can access this after class is finished. So our first step when we're drawing these Lewis dot structures is always to draw the atoms individually. So let me start by drawing the 2 carbons, carbon 1, carbon 2. Each carbon has 4 valence electrons. So I'm going to use my periodic table to remind me that. Or at a certain point, you'll do this so much that you'll just remember that it's got 4 valence electrons. And then there are 6 hydrogens. 1, 2, 3, 4, 5, 6. Okay. All right, I've got to update attendance real fast. Give me a moment. Thank you for your patience. Oops. There we go. Each of the hydrogens has a single valence electron. So I'm going to put 1 dot next to each hydrogen to indicate that they each have 1 valence electron. Okay. So now let me draw the Lewis or the dot structure. Dot structure. I made my pencil fat on purpose because I can make it a little bit less fat. That way I just have to like press for a dot instead of like drawing the dot. If you're wondering why it's so fat. So let's start by figuring out which of my atoms has the most unpaired electrons. In this case, it's pretty easy because each hydrogen only has 1. So obviously it's not hydrogen. Each carbon has 4. So one of these carbons, doesn't matter which one, I just got to start with one of them. Right, so there's my carbon. 1, 2, 3, 4. So I've done that one. Okay, so second, I'm going to put the second most. The carbons have the same, so it doesn't matter. So I'm going to use my second carbon, second. Over here, I'm showing that they are sharing this pair of electrons. This is a bond right here. So they're going to overlap these electrons to form a bond. Okay. Nice. So I've set up my carbons. Now I've got to fill in my hydrogens. I'm just going to go through, and for every empty spot on a carbon, for every single electron, I'm going to fill in a hydrogen. So there's 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6. Nice. There we go. Have I used up all of my atoms? 2 carbons, 6 hydrogens, 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens. Yes. Is every atom touching 8 electrons? 1, 2, 3, 4, 5, 6, 7, 8. Yes, this guy's happy. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this guy's happy. The hydrogens only want to touch 2. They're the exception. 2, 2, 2, 2, 2, 2. Yep, everyone's happy. Big smile. Cool. Let me redraw this. Let me draw the structural formula. Oops. Structural formula. Sorry, very messy. When I draw this structure, I replace those paired electrons with a dash to represent that bond. This is kind of like think of it like a rubber band holding them together. So they're bonded there. He's bonded to a hydrogen, 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 and hydrogen. Done. Okay. So that's my C2H6. And some of you may be asking, Ms. Shaw, that has nothing, there's no double bonds there, right? Like what's going on? Yes, you are correct. I set this one up first on purpose because I want to show you what happens as we start to take away hydrogens. So right now I'm going to give you like 2 minutes to copy this down. And if you've got questions, let me know in the chat. 2 minutes, finish copying this down. I'm going to save this image. Okay. That way I can put it into our slides later and you can access it. All right, just about 30 seconds. I'm not actually looking at a timer. I'm just estimating how long it takes people. Alrighty, so I'm going to clear this drawing and we are going to draw our next molecule. Okay? So our next molecule, we're just got to get my space set up here. Our next molecule is very similar, except instead of C2H6, it's C2H, oops, I got ahead of myself, C2H4, right? So this is from our warm-up. I had you drawing these two and thinking about how are they different. It's the same exact elements I was dealing with before, so I'm going to quickly draw the Lewis dot structure of my individual atoms. Right? I've got 2 carbons, each one has 4 electrons, 4 hydrogens, 3, 4. I draw them offset like this just so it's like clear to me which one's which, because if they're all next to each other, sometimes the dots get confusing. So feel free to like use space, don't crowd it too much, because you want to be really clear about which one's which. Okay. So let me draw my dot structure. For my dot structure, I'm going to start the same way I did for my previous molecule with my carbons, and I'm going to connect my carbons to each other. Okay, so there's my first carbon, done. Let me draw my second carbon, done. I connected them the same way. Nice, so far so good. And now I'm going to start connecting hydrogens. So this first hydrogen, I'm going to connect here, there, sharing electrons, happy, happy. Second hydrogen, I'm going to connect there, sharing electrons. Third hydrogen, I'm going to connect here, happy, happy. And then fourth hydrogen, I'm going to connect here. Okay. Take a look at my molecule and please inform me of my mistake. Please take a look at this molecule and tell me why this is not complete and why I need to fix it. You may not know what to do. That's okay. Just tell me like what's wrong about it. Yep, I'm getting multiple responses. Nice. Here's the 2 responses that I'm seeing. So thank you, Jessica. Thank you, Tasia. Thank you, Denise. Thank you, Lauren. So I'm hearing people say that there's these 2 unpaired electrons. So a few of you have mentioned like, hey, there's these single electrons. I know that's a problem. A couple other people are saying, hey, one of the carbons isn't touching 8 electrons. 1, 2, 3, 4, 5, 6. Bad. Both of you are correct. Both of those things are a problem. So he's touching 8, but he isn't. And there's these 2 unpaired electrons. We're not done. We're not done. Some of you are suggesting in the chat for how to fix it. Yes, you're on the right track. I'll show you how we can fix this. Okay? Please do not erase this in your notes. Do not erase. Leave it there. Okay. I mentioned this last week a couple of times, and I'll say it again. When you are drawing these pictures, this is going to happen where you draw it and it's not correct. It's going to happen a lot, and it's no big deal, right? Okay, I messed up. This is not going to work. No big deal. Put a little X and try again. Okay. I just want to normalize it, like, so that you don't feel like stressed out when you see it, because it happens a lot. It's going to happen a lot to you, right? You're going to make mistakes. That's okay. We can fix them. Okay. All right. So here, my only option, I used up all my atoms. I can't add more hydrogens. Like that doesn't work. I only have 4. My only option for dealing with this is rearranging how they're connected. I know just from experience, I know that the carbons are going to still be connected to each other, right? You can try rearranging it, but you're going to run into problems. So I'll just like skip ahead to the future and get you closer to the answer. I know my carbons are still going to have to be connected. What I did here was I connected 3 hydrogens to 1 carbon and 1 hydrogen to the second. So let me try maybe 2 on this one and 2 on that one and see if that will help me. So I'll put 1 hydrogen, 2 on the first, and then 2 on the second. Okay. So I'm still not done, right? I still have problems. Now I have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So they're still not touching 8 electrons. I still have these unpaired electrons. But with this setup, there is something I can do to fix it. Here, I'm stuck. There's literally nothing I can do with these electrons. Here, I have a situation where I have two atoms that are already bonded that also have an additional electron each. So what they're going to do is they're going to bond again. They're going to form what we call a double bond, right? So that electron that used to be chilling outside here is going to move to the middle, and they're going to bond double. The way that we draw this with dashes is we show two dashes between the carbons to indicate that they are doubled. They are double bound. And then one bond to each of the hydrogens. Before I got a little bit ahead of myself, let me just double check that I've got the right number. 1, 2, 3, 4, 5, 6, 7, 8. He gets to touch all four of those, so this guy's happy. 1, 2, 3, 4, 5, 6, 7, 8. He gets to touch all four of those. This guy's happy. Right. So we are good. Bing, big smile. Each hydrogen is just touching 2. I can see that just by looking at it. So here's what I'm going to do. I'm going to stop talking for 2 minutes. I'm going to give you a chance to copy this down, and I want to open it up for questions in the chat, because this is a little bit of a weird, switchy dynamic thing. So I just want to open it up for questions to see what is confusing you and what doesn't make sense right now. So for 2 minutes, you're copying this down. And if you've got questions, please let me know so that I can support. Yeah, there was a question about like the 8 electrons. They get to double dip, right? This carbon, he gets to touch all 4 of these. So think of it like he's holding these rubber bands that are connecting him to the other carbon. He gets to pretend that they're all his, even though they're not. He gets to pretend. So he, in total, 1, 2, 3, 4, 5, 6, 7, 8. He's touching all 8. All right, just about 30 seconds. Then I'll save this drawing and we'll move on to our final example. I'm gonna go ahead, no, this is fine. Okay. All right, so again, I will be linking these pictures in the slides. So if you aren't able to finish copying them down, you can always go back and access them later. Right now, what I'm gonna do is clear these and go through our final example. Excuse me. Our final example is C2H2. So you can see that I'm removing hydrogens in each step. Okay. Well, it's a terrible line, but we'll just deal with it. Okay. So same atoms I've been using. So I'm going to draw them quickly because I've already figured out how their electrons go. And that's all I've got. I've got the 2 carbons and 2 hydrogens. Okay. So not a lot to work with. So let me start. This is my dot structure here. Let me start by putting the carbons together because they've got the most single electrons. So here's my first carbon, and I'm going to connect it to my second carbon, just like that. Okay. And just before this, with our previous drawing, I saw that like if I put all the hydrogens on one atom, I'm going to have a problem. So I'm using that experience to help me when I'm looking at this one. And I'm going to start off by putting 1 hydrogen on each atom and see if that helps. Sometimes it helps and sometimes it doesn't. I just want to see this time if it helped. Right, so I've used up my carbons. I'm going to put 1 hydrogen here, there. And then my second hydrogen, I'm going to put it on the second carbon because that's what we had to do the last time. So I want to see if this helps. People are already predicting what's happening. You're on the right track. So here, I'm going to make my line real thin. So here I've got a problem, right? I've got these single electrons hanging out. Let me deal with 1 pair of these at a time. So I know that if I've got 2 atoms that are already bonded, and then each atom has a single electron, that I can double them, right? I can take them and make a double bond. So I'm going to do that for this first pair here. Boop, boop, just like that. So then I'm going to erase the electrons where they used to be because they have moved to the middle. But now I have a situation where I have 2 more electrons, right? I still have an additional 2 electrons that aren't paired. So what I'm going to do is bond them again, right? So these guys are going to bond again, and we are going to form what's called a triple bond. The good news is that it doesn't get any higher than triple. Triple is the highest, but it can get up to triple bonds, right? So each of these carbons is connected to each other 3 times. Let me just double check that I've done this correctly by counting to make sure each carbon's touching their 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this guy's happy. 1, 2, 3, 4, 5, 6, 7, 8. This guy's happy. Hydrogen's touching 2, hydrogen's touching 2. We're following all the rules. Okay. Triple bond. So let me draw this. It's going to be 3 dashes between the carbons to show that they are connected in triplicate. Okay. And this is my structural formula. All right. This is a good chance to ask questions if they're coming up. I'm going to save this so that I can put this into our slides later. Good chance to ask questions. A few of you were already making predictions about how this bonding is going to go, which means that you're seeing the pattern, which is excellent. I'm giving everyone a minute to copy this down and ask questions in the chat. Okay. So I think I've gone through 3 examples with you. I've shown you single, double, and triple bonds and how it changes, right? As I have fewer and fewer atoms connected and I have more and more of these loose electrons, I've got to double and triple my bonding. I think what's really important for you guys right now is for you to practice this. So what I'm going to do is I'm going to go over to our altitude card for the day, and I'm going to show you what the assignment is, and then we are going to work on this together. Let me get out of my slideshow. Cool. So here's our altitude card. Remember, this is due tomorrow. So there's a whole bunch of questions here. Please don't work on those questions right now. Please skip those questions. I want you to focus on the worksheet. So if you look at the worksheet, here it is. There are 3 parts to this worksheet, plus an exceeding, if you'd like to do an exceeding option. There's a little bit of like instructions here. Like this one goes over CO2. I'll show you the Lewis dot structure for CO2 tomorrow. Right now, I just want you to jump into doing practice. So part 1 is more simple molecules. So these are relatively simple. Part 2 gets more complicated, and then part 3 is also more complicated. Honestly, part 2 is harder than part 3, although I've done a couple of these for you. Okay. So what I'd like you to do is start trying to draw these on your own. I want to remind you again that if you get it wrong, wrong is relative. Like if you're drawing it and you can't finish, like you have extra electrons left over, totally normal. Just try to redraw, right? Totally normal. I'm going to mute myself, but if you've got questions or concerns, if you need support from me, please reach out in the chat so that I can help you.